Really? You're a subscriber? Are you the only one? I was wondering. Okay. 7-2 is similar polygons, and using ratios and proportions. Polygons are similar. There's two ways to determine polygons are similar: is if all corresponding angles are congruent, and if all corresponding sides are proportional. Okay. I'll explain a little bit about proportional a little later. So here, the first thing we're going to be doing is in this question is, are the polygons similar? Okay. So here, are the polygons similar? We don't know yet, but we know that all corresponding angles are congruent. Okay? So that's the first step. So that's check mark. Next one is, are the sides proportional? So here, are the sides proportionate? Right? So here, we're trying to find a similar factor, also the simplest form. Here's the ratio we're going to be using is small triangle over the large triangle. And here, we're going to compare the segments of AB here and DE. And we know here the value of AB is 4 and the value of DE is 8. We're going to find it the similar factor first, 4 over 8, or find the simplest form. Okay. So here we divide by 4 over 8 by 2, and we'll get 2 over 4. But technically that's not the simplest form. So we can divide 2 over 4 by 2 again, and that'll equal to 1/2. This is the simplest form, and if we look at it here is, you can determine that the simplest form because 1/2, and you look at this pattern here, 4 is half of 8. So it follows the same ratio, right? It's half of, the scale is 1/2, so here 4 is half of 8. Going on to the next one, BC, segment BC here, and segment EF. Okay. Here we know the value of BC is 6. We know the value of EF is, or sorry, BC has a value of 3. EF has a value of 6. And here we can divide 3 over 6 by 3. 3 divided by 3 will be 1, and 6 will be divided by 3 is 2. Once again, the ratio for this is 1/2. 3 is half of 6. And the last one we're going to be doing is AC, which is we're going to be comparing it to DF. And here AC has a value of 5, DF has a value of 10. And here we can divide the small triangle and the large triangle by the value of 4, 5. 5 divided by 5 is 1, 10 divided by 5 is 2. And also, once again, 5 over 10 is the same ratio as 1/2. If the ratio is 1/2, 5 over 10, 5 is 1/2 of 10. Okay. I hope that's easy to understand. And that's pretty much the concept of this lesson is what's the word? This is pretty much the concept of the lesson, which is if you find out that all three have the same simplest form or similar factor or scale factor, then they are proportionate. Yeah. So here, going on to the next one. To write this actually in standard form, here is the scale factor for this is 1/2 or 2 over 1 or 1 colon 2 or 2 colon 1. Oops, sorry. I don't know up higher. So here, how do you write this scale factor properly? Here, you can write it as 1/2, or you can write it as 2 over 1, or you can write it as 1 to 2, or 2 to 1. Okay? And here, I'm going to explain the first one here, is whenever you're writing down the scale factor of 2 over 1, right, it means that the diagram from the right will be increasing, right, 2 over 1. How? Because 2 over 1 is technically 2, right? So basically, you multiply 4 times 2, you get the value of 8. You multiply the value of 3 times 2, you get the value of 6. And you multiply the value of 5 times 2, it will get the value of 10. You see how they carried increase in scale based on the scale factor that we found out. if we do the next one here is when you put it 1/2, right? The scale is going to indicate that if it's 1/2 or the numerator is less than the denominator, then it's going to indicate that it's decreasing in size. Okay, so when the numerator here above is larger than the denominator, then it's going to be increasing. If the numerator is less than the denominator, then you know that it's going to be decreasing, right? Or improper and proper fraction, whichever you want to call it. So here, if you look at from left to right, it's going to be, the scale is going to be 1/2, because if you look at the diagram, the triangle is decreasing. Half of 8 is 4, half of 6 is 3, half of 10 is 5. Okay? And that's how how the scale factors work. And going on to the next example here, we'll just do another example, so don't worry too much about it if you don't understand the first example. Um, so here we have another example here. Once again, we have to determine, are the polygons similar, right? So here, once again, there's two things we need to confirm. Are the corresponding angles congruent? We can already look at both of the polygons and determine that. Angle L is congruent to angle W, angle M is congruent to angle ZX, angle N is congruent to angle Y, and angle P is congruent to angle ZY, because all the angles equals to 90 degrees. Okay. So now here we're not saying that it's not similar yet. We have to determine that, are the corresponding sides proportionate. Then we can determine that the polygons are similar. So here, once again, the last ratio we did was different from this one here. The last ratio was small triangle over big triangle. Now we're gonna kind of do it differently. Here we're doing the big polygon over the smaller polygon. Okay. It's not really different. It's just how we chose to organize it. We just have to be consistent. LP is going to be proportionate to WZ, which has a value of 12, and WZ has a value of 8. And then when we're doing this, we can divide 12 and 8 by 2, and maybe 6 over 4. We can still divide that more, simplify that more by 2 to get the scale factor, similar factor of 3 over 2. Next one here is LM, has a value of 12. LM has a value of 9, and it's corresponding to WX, which has a value of 6. And here, when we simplify 9 over 6, we can divide that by 3, and you'll get 3 over 2. Well, here we notice here they have the same ratio, or simplest form or scale factor. We're kind of already in understanding that they already are proportionate. Why? You don't have to check for MN and XY. Why? Because you already found out the opposite side, right? Their proportionate is 3 over 2. So here the ratio for MN and XY is already going to also be 3 over 2, right? MN and XY will also have the ratio of simplest form or scale factor of 3 over 2, because it's the same as LP and WZ. Next one is PN and ZY. Once again, you don't have to do it again. Why? Because you already did LM and WZ, which these two sides are congruent to. 9 is congruent to 9, and ZY is congruent to WX. So here it's the same thing. 9 over 6, 9 over 6 simplified to this form, it's still 3 over 2. Okay. And here, just disregard this. This is just a shortcut to 12 over 8. You can always divide it by 4 straight and just be 3 over 2. And here the scale factor, once again, or before we do that, here we already acknowledge that the polygons are similar. Why? Because all the angles are congruent. So let's put a check mark on that. And here, are the corresponding sides proportionate? Yes, because all of each side has the scale factor or similar factor, which is 3 over 2. Okay. If you notice, if 3 over 2 here, it's the same thing here, saying 12 over 4 is another saying of 3 over 2. Because when you multiply 3 by 4 and 2 by 4, is 3 times 4 is 12, and 12 times 4 is 8, right? Here, or you're doing reverse, right? You multiply 3 over 2, when you multiply 3 with 3 and 2 by 3, it'll be 9 over 6. And that's pretty much it. So here, okay. Going on to the next one, okay? Here, determine are the corresponding angles congruent. Here, we cannot say that they're congruent yet, right? Because here, I know it's you see a tick mark here, but it's not emphasizing that they are congruent because there's no given value. If there was a given value, like if this was actually, let's do that. I'm gonna put a value here which is 80 here, okay, and I'm gonna put a value here which is 80. If it's 80 here, then this will be 100. Will be 80 here because base angles are congruent. And this is 100. And here, I'm not gonna put it down there, but here, if you see 80 here and 80 here, then automatically, if you see all of them congruent, then automatically assume that this is gonna be same side interior angles, right? Or base angles are congruent, same side interior angles. So here, with this fact alone, since we know that this is 80 and this is 80, we can already do that. Angle F here, or angle B and angle F is going to be congruent because they're both equal to 80. And we know that angle C is congruent to angle G. Why? Because base angles are congruent. If this is 80, then this other base angle is going to be congruent. It's 80 as well. And here, angle A will be congruent to angle E. Because why? Here, if the base is 80 here, then you know that the opposite base is going to be supplementary, which equals to 180. So 180 minus 80 is 100. So angle A is congruent to angle E. And the last one is angle D is congruent to angle H. Because once again, base angles are congruent or angles are supplementary in a trapezoid. Okay. So here we know that all corresponding angles are congruent. Now we're going to determine are the corresponding sides proportional or proportionate, whichever you want to phrase it. So here is going to be, once again, it's how you want to write it. It depends on you. You can write it any way you want it. That's the way you need it, right? Big polygon over small polygon. It's up to you. Here we're going to first compare AB is corresponding to EF, right? AB is corresponding to EF. The value for AB is 7, and the value for EF is 5. If we're going to put this in simplest form, this is already in simplest form. You can't really find any value unless you want to. If you can, then that's going to be interesting. So this is the simple form, 7 over 5 for the scale. 7 over 5 or 5 over 7. It's up to you how you want to write it. So here is DC and HG. I'm just putting this because you know that the two sides are congruent, whatever it's given. So we'll just put that down. They are, or these two sides are proportionate already. Now we're going to determine if the top part is proportionate to EH to both of the sides we just found out, right? AD is going to be 14, EH is 10. We can simplify AD, value which is 14, and value of EH which is 10 by 2. 14 divided by 2 is 7, 10 divided by 2 is 5. Once again, it has the same simplest form or scale factor. And the last one is BC and over FG. BC with the value of 21, FG with the value of 15. And if you divide this by 3, 21 divided by 3 is 7, 15 divided by 3 is 5. Okay. So here, our conclusion is, since we know that all the angles are congruent, we know that all the sides are proportionate, then we can make a conclusion that polygons are similar. And scale factors, the scale factor is 7 over 5, or you can write it as 5 over 7, or you can write it as 7 to 5, or 5 to 7. And here, don't forget, if the numerator is larger than the denominator, then the diagram will be increasing. If it's 5 over 7, then the diagram will be decreasing, and so on. I don't want to draw it again, because I think if I draw too much, you'll probably get confused. Just notice that when the numerator is larger than the denominator, then it is increasing. Whenever the numerator is less than the denominator, then it's decreasing, pretty much. So going on to the next part of the lesson, I'm going to be, hold on, let's clear this out. So here, this is the next part of the lesson, which is going to be, it's going to ask us find the value of x with the similar scale factor given, or give it with the similar scale factor. Here is just the given here. The given is the similar scale factor that's given to us is 2 over 3, or you can write it as 3 over 2, or you can write it as 2 over 3, or 3 over 2. Yeah. So here we're going to find the value of x, and just something that we're going to be. It doesn't really matter what you choose, right? It really all depends that if you put 2 to 3, right, then you know that 2 will represent the 2 is representing the small polygon, and 3 represent the larger polygon. That's using common sense, right? And now equal to. Now again, here we're going to be using the same ratio on the right, which is small polygon over large polygon. And I hope everyone can see what I'm writing, because there you go, yeah, it's there. So small polygon over large polygon when you're using the scale. Okay, that's what I would do in my opinion. Here is how do we get 2 over 3? Once again, it's given to us, right? And then here we're going to be writing down our small polygon, which has the value of x, and the large polygon, which has the value of 42. And these two sides are, once again, corresponding. Oh, I apologize, one more thing. That's another given here. I forgot to mention. The polygons are already proportionate. I forgot to mention that. Here it's telling us the polygons are already proportionate. So what we're going to do is we're given the scale factor. So we're trying to find the value of 42 and x. Yeah. So here, how we're going to find it here is we're going to be using cross multiplication. And you can use cross multiplication. In my opinion, only use cross multiplication when you are doing ratios and proportions. A lot of students, they get confused and they're always trying to apply cross multiplication on concepts they don't really understand, and it confuses them really hard. So in my opinion, never do cross multiplication unless you're dealing with ratios and proportions. You can use it in a different way, but that's my opinion, of course. So here, what we're going to do is 2 over 3 is equals to x over 42. What we're going to do is we're going to cross multiply. Once again, only do cross multiplication if you're going to do if you're using ratio proportions. 2 times x is 3x, and 2 times 42 is 84. You're going to divide by 3, and x will equal to, I don't know, what is it, 28? Please confirm that if I'm wrong, then oops. X is 28, and how you write this down here is the proper form of writing down this down is going to be 28 over 42. Okay, once again, this representing the small polygon, and this representing the larger polygon. Once again, when working with ratios, make sure you are creating, you're relating two things, and make sure you're consistent when you are comparing. So you notice here I put small polygon over large polygon, small polygon over large polygon. Here it's still consistent, right? It's gonna be small polygon over large polygon. So that's the kind of like the interest. That's what's intricate about ratios, is just being consistent when you are comparing. Okay, going on to the next one is going to be one. I'm gonna tear it here. Okay. We're going to example number 2. I'm going to try to do the same thing, right? So here, example number 2 is, what I'm going to do this time around is, once again, I'm still getting the scale factor of what's given. It doesn't change, okay? This is just an extension of the given that we were given earlier. Given is that the scale factor is still 3 over 2, or 2 over 3, or 3 to 2, or 2 to 3, okay? That's the scale factor, and here, using the scale factor, it's asking us to determine the answer of x. I know I already saw the answer, which is 27, but I apologize for that. Just imagine it's not 27. Okay. So here, I'm going to compare. It doesn't really matter. Once again, here this is an example. What if I chose 3 over 2, right? It doesn't really matter. Just make sure you are comparing, acknowledging that 3 will always be using the larger polygon, right? Because it's 3 is larger than 2, and 2 will represent the smaller polygon, okay? With the scale factor that is given to us. Okay, going to the next one. Here is the larger polygon's value. Here is given to us is x, and over 18, which will be representing representing the value of the smaller polygon. Okay, let me cross multiply. 2 times x is 2x here. 2 times x is 2x. 3 times 18 is 54, right? Oops. When you multiply 2 times x, that is going to be equals to 2x. And we multiply 3 times 18 is 54. We divide 2 on both sides. Then 54 divided by 2 is going to equal to 27. Okay. And when you write that in proper form, then how to write that in proper form is going to be, take this down here, it's going to be 27 over 18. Okay, and that's pretty much it. Going on to the next one is this one here is it's given to us that triangle ABC is already proportionate to. So if you see this, it's kind of like a toothpaste, same thing as congruent, but without the equal sign. This means that it is proportionate. So triangle ABC is already proportionate to triangle DF. So knowing that they're proportionate, now it's asking us find the value of x and y. Okay. There's a long way to doing this, but I'll just show you the short way. To find this, you already know that all the sides are gonna be all the pairs of sides are gonna be all proportionate, right? So here I'm gonna be writing all three down, which is gonna be I'm gonna be comparing AB and ED. AB has a value of y, and E has a value of 10. Once again, this ratio I'm going to be using is small triangle over large triangle. So here, BC is 2, and EF is going to be has a value of x. Once again, small triangle 2 over big triangle. Small triangle over big triangle. Next is AC from the small triangle, and ED from the large triangle has a value of 15, and that will be 6 over 15. So here we found all three sides, and we're going to be using their ratios to find the value of x and the value of y. So here we're going to be using 6 over 15 because that's a consistent ratio that we're going to be using to solve for x and y here. So here, the first question that we're going to be doing is if you want to find the value of y first, we're going to be using 6 over 15. And will be equal to the proportion of y over 10. And all we have to do is just cross multiply those two ratios here. 6 times 10 is 60. 15 times y is 15y. 6 times 10 is 60. And oops. Okay, so once again, I'll repeat that. We're going to be using all three ratios to find the value of x and y. So here I chose for this two ratio, I'm going to choose 6 over 15 because this already has a complete ratio, 6 over 15. Unlike the two other, it's not complete. And we're going to answer first for y is 6 over 15 is equals to y over 10. And what we're going to do is cross multiply. 6 times 10 is 60. 15 times y is 15y. Next step is to divide, right? 60 divided by 15 is going to equal to 4. Okay. And here, to write this down properly, it's going to be 4 over 10. This next one is we're going to be doing is we're still going to use 6 over 15. You can use 4 over 10 since you already know the complete ratio. But if you want to just make it easier since you're already working with 6 over 15, then just work with 6 over 15. And the other ratio, which is to find the value of x, which is 2 over x. Just cross multiply. 2 times 15 is 30. 6 times x is 6x. Divide 6 on both sides, and x will equal to the value of 5. Okay. And to complete that is 2 over 5. 2 over 5. Okay. That's pretty much it. If you want to double check your work, you can always simplify them to simplest form. If you're unsure of yourself, once again, you can divide 4 over 10 by 2. And that'll equal to, 4 divided by 2 is 2. 10 divided by 2 is 5. So it still has the same ratio as 2 over 5. If you want to divide this by simplest form, you can divide 6 over 15 by 2. And that will equal to 6 divided by, 3. If you divide 6 by 3, that will equal to 2. Divide 15 by 3, that will equal to 5. Once again, you still have 2 over 5. Okay. Once again, that's just if you want to double check your work. You don't have to do this. That's just more work. And the other way, I'll show you the second way though. If you want to know for sure, then you can compare it by 6 over 15. And you can compare it with 4 over 10 or 2 over 5. It's up to you. Let's just do 4 over 10. If you want to double check your work to make sure that y is correct, it really 4 over 10 is, you can cross multiply these two. And if they're equal to each other, then you can say that they are proportionate. So here 6 times 10 is 60, 15 times 4 is 60. If the two ratios are equals the product of the two ratios of the product of each cross multiplicated ratios are equal to, if they are equal, then they are proportionate. I don't know how to phrase that. Hope that's not too complicated. You can also do it for 2 over 5 if you want to, right? 6 over 15 equals to 2 over 5. 2 times 15 times 2 is 30. 6 times 5 is 30. So that's another way, once again, to determine if they are proportionate if you're not sure of yourself. Okay, but you don't have to do this. But it's good to double check your work, of course. Okay, last one we're gonna be doing is we're gonna be about the same thing. Okay, the only thing we're gonna be different here is, once again, the polygons corresponds with one another, or the polygons are proportionate. So put are proportionate, and all we need to do is determine the values, right? We're trying to determine the value of x and the value of y. What you need to do when you encounter this kind of question is just make sure you draw the smaller polygon and the larger polygon apart. If you don't want to, then you don't have to. This is just my way of doing things, of course. I like to draw it just to make it easier, and also it's easier to explain. So the first ratio we're going to be doing is small polygon over large polygon. Here, the first thing I'm going to do is 18 over 24. Next one is going to be 9 over y. And the last ratio is going to be x and over 21. Once again, it's small polygon over large polygon pattern. 18 over 24, 9 over y, x over 28. Okay. And then here, once again, we're going to be using this as a basis because this is a complete ratio. 18 over 24, and we're going to be solving for x. Okay, to be solving for x, okay, we're going to cross multiply again. 24 times x is 24x. 18 times 28 is 18 times 28 is going to be 500 something. 504. Okay, 504 and equals 24. 18 times 28 is 504. 24 times x is 24x, and all you have to do is just divide both part of the expression by 24, and you get the value of x, which equals to the value of 21. Hold on, let me write it better. 21. Okay, and how do you write that properly? X over 28 will become 21 over 28. Okay. Next one is, once again, you can choose 21 over 28 since it's a complete ratio now, or you can still stick with the same ratio, which is 18 over 24. And we're going to use the last ratio to solve for y. Again, all you have to do is just cross multiply. 18 times y is 18y. 9 times 24 is equals to 216, I'm guessing. Okay, 216. So when you divide 18 on both sides, that's going to equal to 12. Okay. And once again, if you have the value of a 9 here, 12, then you can always complete the ratio, which is 9 over 12. Um, just in case, once again, you want to double check your work, all of the ratios here, if you simplify it, it's going to be having the scale factor of 3 over 4. This is the ratio, 3 over 4. And you can always verify here, if you multiply this, 9 is 3/4 of the value of 12, right? All you have to do is just multiply. If you do 3/4, to get the value of 9 over 12, just multiply the scale factor by 3, and you get 9 over 12. Yeah, that's how the scale factor works. They're all kind of related to the scale factor. Here, this one is 21, right, over 28. Here, once again, you by multiply the scale factor by 7 each. 2 times 7 is 21. 4 times 7 is 28. So here, once again, they're still proportionate to 3 over 4. And the last one is going to be 18 and 24.